Claremont 3D Design, high-level presentation of services and method of work. We're a group of engineers experienced in the full spectrum of project management, from concept through to construction, commissioning and handover, in both client representative and contractor roles. Experience in compliance with standards required for work in hazardous areas, including ATEX, aging plant, CDM, control of major accident hazards, pressure equipment and safety regulations, reporting of health and safety issues, and CE marking. The majority of engineering contracts are managed in the following manner. The client puts together a vague scope of work as they don't have the resources to carry out the front-end engineering to fully define the scope, so are forced to estimate the time and cost for the funds to be allocated. The client requests the contractor to provide a cost and time schedule for delivery of the entire project, expecting them to account for the missing information within their quote. The contractors know the scope of work is lacking detail, so bid low with a host of exclusions in order to win the contract, with the strategy of hitting the client with variations to make money back later. The client is aware of this, so tries to get the contractor to do as much as possible for the minimum amount, as their budget was limited by their initial scope. As the project progresses, a host of issues are discovered which expand the scope of work. The contractor is wary of doing tasks for free as they have to work to their budget. So between the two parties, a bureaucratic exercise is created to document the differences between the original scope and what the project actually requires to complete the work. This places stress on the engineers to deliver the scope of a constantly changing project to the same deadlines, as well as gathering and documenting all the data to justify the variations. This political game playing is extremely harmful to relations between the parties, as the engineers become pawns to justify the costs, which they were not initially involved with, and good engineers with other options will simply leave, making the project even more difficult to deliver. The end result is a project delivered late and over budget. We'd like to see this change, and as a result have developed a lean method of work which defines the technical scope of work at concept to deliver project to realistic time and cost estimates. Scopes of work are based on practical solutions with construction build sequences. This requires more time in the first phase to correctly document locations of equipment, space required, and any practical issues to deal with in order to enable the works. These details are necessary to pin down the scope of work and enable early engagement of suppliers for confirmation of equipment specifications. This method of taking extra time to work on these issues early vastly reduces the need for redesign and associated time delays later, making the following phases of work more efficient and less stressful. Method of work. Phase 1. Concept or front-end engineering design. The most efficient method of working is to form a team which incorporates into the client's structure to make use of their on-site knowledge. Following surveys of the existing areas and equipment, isometric layouts are created. Proposed locations of equipment with physical sizes are added to the layouts, enabling the basic process calculations and other discipline parameters to be defined. For brownfield site surveys, the identification of existing services for extension, including power supply and instrument air, are also recorded. The physical representation of real-world information is incorporated into the initial design, forcing early solutions. This information enhances the understanding of work required for more practical process logic diagrams and written descriptions of the scope of work to outline stages of work in order. The end of this phase produces a pack with technical information, layouts and process flow diagrams, along with time schedules and costs, to 30% accuracy given the available information and estimates of Phase 2. Design. Upon agreement of cost, scope and time schedules, the project workflow is tailored to suit project specifics. Building on Phase 1, the engineers advance the content to narrow the scope of work. These higher level details assist layouts, the construction sequence and P&ID process reviews, along with practical fabrication and installation information. Each discipline combines their work to produce equipment datasheets along with the mechanical, electrical and instrument contracts for the suppliers. The quotes from suppliers and construction contractors are more accurate as the scopes of work refer to the practical layouts which are in the visual language required to understand the build, so construction issues are raised and dealt with as early as possible. The construction contractors competitively bid after a site walkdown. These quotes are compared in a technical bonus malus. to select the suppliers, then costs and schedules updated to suit the realistic lead times and orders are placed. A 3D model can be created if required, but the use is limited to show locations of equipment for layout reviews, clash checking in congested areas, reassurance to client of progress and volume calculations. They are of almost no practical use to the construction team at the workface, so unless the client requests a model, there is a threshold to pass to justify this creation. This comparison demonstrates the point. The 3D model on the left was created by a large, well-known design company and only shows the new flanges to connect with. It does not show the location of existing nozzles on the vessel or location relative to any existing reference. The model also does not show which services the pipes carry, tag references of inline equipment, or even pipe size and spec, with the user having to refer to multiple other documents for this data, whereas our ISO layouts contain all information for easy construction information, making reference to P&IDs and fabrication drawings much easier. The construction contractors use the ISO layout in favour of the model during this build. Once all documents are complete for Phase 2, we're ready for Phase 3, site works. The layouts are used to communicate all construction activities, from bringing contractors onto site and setting up the compound to laydown areas, showing step-by-step movements for each party to coordinate work required. Work starts after pre-task meetings to walk through the construction sequence with all required parties. Once permits are signed and work commences, the contractors are guided by continuous engagement, which includes audits, problem-solving on-site issues, including management of change, and contract conflict resolution. As work progresses, the layouts are updated to show as-built progress, recording of snags and commissioning activities before work areas are signed back over to plant control once complete. When the construction phase is finalised, move on to Phase 4, post-works. As-built information from the contractor is used to update P&IDs and layouts, then incorporated into the project handover pack. Other activities to close a project can include HAZOP 4 to confirm all requirements are met, creation of operating procedures, maintenance requirements of new systems, and technical support for any reliability issues. Finally, lessons learned will be carried out to identify improvements we can make in delivering future projects. The end of the project produces an as-built interactive pack which can be used for all future works. Any and all documents can be hyperlinked on P&IDs and layouts, making tasks faster and easier. Over time, the projects undertaken build up a more complete picture of the site, so that projects pay for the update of full site records. This built-up site layout with fast access to documents also assists with services for maintenance, reliability and EHS issues. Evidence that this method results in delivery of projects on time and within budget are presented here, with 4 recent projects all delivered within time, cost, scope and safety plans. For details of projects worked on, please see other presentations. In order to enable a successful project delivery, here's what we cannot do. We cannot go back in time and change an agreed contract with suppliers. Starting work to then go back and redefine a project scope while the work is already ongoing, while also trying to define the next phase of work, is very high pressure and stress. This results in items being missed and mistakes made. The best solution to avoid rework and additional charges is to freeze where it currently stands and redefine the scope of work. Previous contracts have been in service to these companies.